Welcome again, everybody. Thanks for being here. This is the first official UF BME Industry Insider Seminar, part of a new series that really was envisioned by Ryan Letzinger in our department, and so a big thank you to him and Candy Crimmins who helped us get everything going. Today, it's my real pleasure to introduce our first speaker. So the inaugural speaker of the seminar series, Duane Chin. He has a bachelor's degree from UF. His email that you see on the screen kind of says it all. We're about the same age. He actually graduated in '99 from the biomedical engineering science and mechanics program. And for the past 18 years, he has been working for NASA, which is really cool. And he's going to share his experience with us. His current position is a medical operations manager. And the other thing I want to say is what's really fitting for today is I already mentioned this is the first seminar in our series, new series, and it's really perfect that I think that Duane is kicking everything off because as you can tell by his major, he was really a BME before there was BME here at UF. And that's the reason that's so important for today is the objective of this series and what Duane's going to talk about is really to expose most of the participants on the call, the students, to what it's like to be a BME in a career. So what it's like to navigate through a career path. And what I've learned is it's all about finding your fit. And so for me, Duane is going to be a wonderful example of how a biomedical engineer can find their fit in an industry, especially one that you think is not biomedical engineering, like aerospace or everything having to do with NASA. So with that, we'll turn it over. Duane, before I give you the reins, I'll mention a couple of administrative things. Duane's going to talk for 20 minutes or so, and then we're going to open it up to discussion for everybody. While he's giving his talk, though, if you have a question, feel free to chat it in the chat room, and we'll keep note and we'll make sure that it gets asked. So. Okay, Duane, any questions before we get going?
Nope, nothing.
Okay, great. All right, now with that, I'll be done talking and it's all yours. So go ahead.
Okay, well, thank you, Lee, for that introduction. Yeah, like you said, I guess, you know, I was in the early program, so it wasn't really a fully BME program, but they were trying to define what it was. I will say I'm really glad to be here to talk to the biomedical engineers that are in the program now. And I will just reiterate what you said, that there's a lot of times when, you know, we get pushed into a corner of what engineering should do or what it should not do. I think when we talk about my career here, you'll see some of the things where you could kind of do what you want to do and fit in where you need to fit in. So I'm definitely an example of that. And we'll talk a little about it. So here we go. So there's my first slide. That's my name, Duane Chin. That's my email. I'm open to, you know, if you want to ask me questions after this, I'm open to emails and going back and forth. I have spoken with high school students and college kids and given advice. I'm a big advocate for BMEs and space in general. So any questions, feel free to contact me. Okay, so there's my first slide. So just a little bit of who I am. I grew up in South Florida, in Miami. I went to Miami Sunset Senior High School, pretty much lived there all my schooling life. And then on the second bullet there, I kind of was graduating high school, kind of don't know what to do. So I applied to all the state schools and it was obvious that, you know, it was obvious to me what the choice should be. I should be a Gator. So part of what went into that decision was UF was a really, well, UF still is, but at the time was really a big school. A lot of the other in-state schools weren't at the size or the level that UF was. So it offered a lot of opportunity. For someone who was coming into college not knowing what I wanted to do, it gave me the opportunity to kind of figure out what I wanted to do. And, you know, ultimately that choice paid off for me because I ended up in something that I really love and I do something that I really enjoy today. So I feel like it was a good choice. So just to give you some perspective, I'll talk about my UF career. When I went to UF, you know, I lived in Hume dorm. It's my understanding now, I think it's an academic dorm. But when I went there, I ended up, not by choice, living on the only quiet floor on the entire campus. So what that meant was, I think it was no noise after 8 o'clock. Yeah, so for anybody who's lived in a dorm, you pretty much know how crappy that is. And we actually also had an advisor live on the floor. So there was a teacher that lived on the floor. Again, not by choice, I ended up on that floor. And then also where the Current Rights Union bookstore is, that was a sunken parking lot. So you would drive down and there was a parking lot there. And now there's this huge bookstore. So that was many, many years ago. And then the thing that I tell a lot of current students now with the onset of the internet is, when I was in school, our drop ad was done over the phone. And if a class was full, you had to go to the professor's office to get added to a wait list, or if a spot opened, you had to go to the professor's office to secure that spot. You had to get the professor's signature on a piece of paper. So again, many moons ago. And for those who, I'm pretty sure everybody follows Florida athletics, you know, when I started, we had no national championships in football. We now have 3. We had no national championships in basketball. We now have 2. So, you know, as an alumni, I'm an avid Gator fan. I follow pretty much majority of the major sports. And, you know, my friends and I who graduate, we get together frequently to talk about and go to games and stuff. So that's a part I really enjoyed. So initially when I started, you know, not knowing, I kind of looked into zoology. I went into the zoology world major, did that for a couple of years, and I just realized it wasn't what I was looking for. So I transitioned to, again, it says biomedical engineering there, but at the time it was engineering sciences, which was a part of the College of Aerospace. You would get a minor in biomechanics. A lot of our coursework was focused on physiology and the biomedical side. You take organic chemistry, you take physiology. So ultimately you ended up with a lot of pre-med students or pre-law students, but that's kind of where I ended up. And I feel like I say that it was one of the best decisions I've ever made. Don't tell my wife that, but it was a pretty good decision, I thought, career-wise, because what I do now, it kind of matches me to a T. So, and what kind of drove some of those changes to end up in that major? I had an interest in the medical industry. You know, I always kind of didn't want to be a clinician, didn't want to be a physician, but the medical industry and helping people always interested me. I always was very technically, I don't want to say good, but I enjoyed dealing with technical things, designing things, solving problems. Initially, I thought I would end up doing prosthetics, something in prosthetics and orthotics, but ultimately that didn't happen. Okay, so in getting my job. So once you graduate, the big thing, getting your first job. First of all, at the time, UF, when I graduated, the graduate program was in its first year. So I wasn't interested in going into the graduate program, so I wanted to get out into the working world and kind of do the next thing. So first thing out of school, I ended up working for this small company in Orlando. It was with rehab equipment, so wheelchairs and positioning devices. And I did a lot of repairing and customizing wheelchairs, high-end wheelchairs. So when you see people who are paraplegic or quadriplegic and they're in motorized wheelchairs and they have, you know, alternative devices to drive chairs because they can't control the chair with their hand, they use sip and puff or motion or those things. So that type of level. And then from there, because I'm an engineer and I kind of just got entry into that industry, I had a desire to do more. So I went on to this small company that was owned by Hopkins, designing wheelchairs. Did that for a couple of years, and it was a lot of fun because there's no better feeling, you know, and I get this a lot in biomedical engineering, a lot of things I do, you get the immediate feedback of you give somebody something. And in the rehab industry, you're giving people who have no mobility a lot of mobility. And it was a very satisfying thing. And then that second job was in Baltimore, Maryland, because it was a part of Hopkins, and I had a desire to move back south, get closer to Florida. And then this opportunity came up to work at NASA in MCC. Obviously, it's not in Florida, but I thought in my simple mind that I could go there and somehow transfer into KSE and work at Kennedy. Obviously, that didn't work out because I'm still here 18 years later. And what I realized is KSC does very different things than JSC. So my NASA career. So when I first got here, I started as and this is a job title, biomedical flight controller, and that's still a job title today. I basically sat in MCC. You see the top picture there on the left, that is the International Space Station Control Room, MCC. I would sit at one of those terminals and be the sole responsible point of contact for all the medical equipment that's on International Space Station. So for anyone who's seen the movie Apollo 13, those guys with the sleeveless shirts and the black straight ties, string ties, those are also flight controllers, and they were responsible for different systems. Basically, every system on ISS has a representative in that room. Mine was just medical equipment, which we call CHECS, which is everything at NASA has an acronym. It's Crew Health Countermeasure System, and that includes everything from exercise equipment, environmental hardware, medical equipment, AEDs, a lot of testing. So it's quite diverse amount of hardware. So traditionally, we hire in biomedical engineers to do that position. And then for what I like to call the bags of water, which are the astronauts, the flight surgeons are responsible for any healthcare of that crew member. So we work obviously very close with flight surgeons to take care of crew, because the medical equipment goes hand in hand, and it's almost a partnership. So I have on there operations. So I kind of highlighted all the things that I did overall big picture. So that was kind of an operations life. And then after about 5-6 years, I transitioned to more of a research-based job. Human Research Program is a organization within NASA that solely focuses on figuring out how we're going to do long duration mission beyond low Earth orbit. So that's LOE, and that's a huge challenge. From our standpoint, low Earth orbit is easy, because we basically can get up and get down fairly simple, and the comm delay and the time delay to talk to crew members is pretty much zero. So long duration missions beyond low Earth orbit, even to the moon or to Mars, there could be up to 16-minute comm delays. So how do you do telemedicine with 16-minute comm delay for an astronaut who is vitally ill? That's the challenge. So XMC, which is one of the 6 elements of HRP, they are responsible for figuring some of that stuff out, and there's a lot of research involved there. And then from there, I moved on to work some new emerging programs. I'd say within the past 7 or 8 years, NASA has really opened up the amount of programs they have to develop vehicles and future missions. So there's a list of them there. Constellation, Orion, Commercial Crew Program. A lot of you are probably familiar with the Commercial Crew Program. SpaceX is one of the providers, and they recently launched a Dragon vehicle to ISS. That was a huge milestone. Personally, I was there at the beginning in 2009 when that program was kicking off and writing requirements, but I never thought we would get there, but Elon Musk got there, and it's been a tremendous success. So, and I think it's going to be a big part of NASA going forward, not just for vehicles, but for how NASA does business, how they interact with businesses and get work done. So a lot of planning there, because there's a lot of systems engineering involved, requirements development, verification of requirements and design, hashing out design. That's why I kind of have planning there. So the last bullet on here is kind of where I ended up. So this is where I am now. I am the manager of medical operations team. The medical operations team kind of includes all those first 3 bullets, but the majority of it is the operational support of ISS. I do work for a company called KBR. Our contract that we have is Human Health Performance Contract. If anybody knows anything about government work, there's contractors and civil servants, and NASA, I guess, sets contracts and lets contracts that companies win, and that's how work is performed. So I felt like, getting to this point in my career, 18 years later, it's really a culmination of taking pieces from each part of my jobs at NASA and putting it all into play of where I am currently now. And ultimately our goal, and it's a goal we say here at JSC, is, it's crew first. So it's safety first. If we see something that's not safe, we speak up, we talk about it, we decide what is safe. There is some level of risk acceptance. In the past NASA, there has been some mishaps, and there was levels of risks that were being accepted when those things happen. But the reality is space flight is risky. That's just the reality of it. It's hard to do what we do, it's hard to get somebody off the ground and keep them in space for 365 days a year for over 20 years now. So it's not an easy thing. A lot of what that last sentence on the last bullet, a lot of what I do now is resource management in this management role, managing deliverables, technical content. I'm a little farther away from technical work, but managing those deliverables, and of course, politics. Everything has politics, and there's a lot of it here at NASA. So next bullet here is kind of talk about human spaceflight and what the future is. So in where I sit, it's pretty bright. There's a lot of things coming down the pipe, and SpaceX is just the beginning of it. Commercial spaceflight industry is off the ground, as you saw with SpaceX, and it's expanding daily. So I think NASA learned a lot how they interacted with SpaceX. And for those that don't know, Boeing also has a crewed vehicle that they will be launching at the end of this calendar year, which is in the same boat as the SpaceX Dragon vehicle. But NASA learned a lot about how they interact with SpaceX and Boeing. And I think they're going to apply that to future work in terms of landers. They want to go back to the moon, so there's landers that have to be developed. There's vehicles that have to go to Mars. There's other space stations around the moon. The reality is, in the past, NASA has, for those that aren't familiar, NASA has developed their own vehicles. They're control of everything. They're control of design, requirements. Every little decision is run through NASA. So when we say commercial spaceflight industry, basically NASA is giving money or buying a seat on something, and someone else is responsible for that design. SpaceX is responsible for the design. We'll give them a high-level requirement. You have to keep the crew alive. They have to figure out how to do that. If it was a NASA-developed program, NASA would detail exactly how to do that, control every step of the way. But the reality is, cost-wise, it's easier, or it's less cost to do it commercially, because SpaceX has benefits, and they could use that vehicle for other things. It doesn't have to be for NASA. They could pay for have rides to go to other space stations. So there is incentive for them to be successful. NASA has a lot of collaborations worldwide. There's a lot of interest in space. There's just a list of a couple of our international partners, which is ESA, the European Space Agency, which is all the major European countries are part of that. RSA is Russian Space Agency, JAXA is Japan, and CSA is Canadian Space Agency. So they're all involved in International Space Station. They all want to be involved with NASA in future endeavors. Again, the future for space is pretty bright. So the ultimate goal is, how do we get to Mars? We want to go to Mars. Something we've never done. It's a challenge. We'll learn a lot from it when we do it, but it's just a really hard thing to do. So there'll be some incremental steps, and one of those will be going back to the moon. We've been to the moon, but this is not just landing on the moon. It's living on the moon. It's living in a reduced gravity environment. It's learning how to do that. There's also a longer comm delay, so there's just dealing with that also. And then, the last bullet on there's my inspirational: as long as we're sending humans into space, which I call bags of water, there will be a need for a biomedical engineer, because we'll have to keep those astronauts alive. So, for any presidential program that says we want to send robots somewhere, I'm not for that. I'm more for that, send the astronauts somewhere. But it is, and I think that will be, astronauts will be a part of the space program as long as we have one. So there's definitely a role for biomedical engineers. And there's a few jobs that biomedical engineers can do, and we can talk about that when we ask questions. But at my company, there's also the design hardware piece. There's biomedical engineers that design some of that hardware that I talked about that was part of the checks. The operations is obviously what I do, and then research to reduce risk, which is very broad. And those are just kind of some of the things NASA can do. So this is the fun stuff, and I just thought I'd throw a couple pictures in there. I'll talk about them. So the three on the top and the one on the right with me opening my flight suit there that's a vehicle in a KC-135. It's an airplane. It's basically gutted, and what that plane does, it flies parabolas. So, you get about, in one flight, you get maybe 30, 40 parabolas, but at the peak of the parabola, when you're going, you're going up on the front end, you'll catch some G's, and then on the peak, you get about 30 seconds of weightlessness. So it is a good analog to use here on the ground, not in space, to learn how to do some stuff. So, I was lucky to go up there to test some techniques. You see that first picture, I'm doing CPR. That's inverted CPR. How do you do that in a zero gravity environment in space? It's a hard thing to do. So what I'm doing there is I'm putting my feet on the ceiling and pushing down to do compressions in case we have to do CPR on Earth. I mean, in ISS in space. And then the second photo there on the top is, if you can't really see it, but that's an arm. So that lady there, obviously in 0G, her hair is floating. I'm trying to do an IV. I'm trying to set an IV in an arm, find a vein, put an IV in case somebody on space had to do that. And then the last one on the top right, you really can't see, but if you see there's a simulator down there on the right, and what we were doing is we were trying to intubate somebody. So how do you intubate somebody through their throat, through their laryngeal canal to be able to help them to breathe? Because we have respirators on board, we have oxygen on board, and in case somebody goes down because of a fire or some toxic release and we need to intubate, that may be the only way to save them. So there I'm trying to, test out, look at procedures. And then obviously that bottom picture on the right, that's a popular thing that everybody likes to do. They like to represent their school. I'd love to get more Florida grads here at JSC. There are a few, but I'd love to get more. And then the last thing I want to say is in the bottom two pictures on the left, the one on the left, that's one of the new vehicles that NASA is developing. It's an Orion vehicle, maybe called multi-purpose crew vehicle, MPCV. That's me sitting in a reclined position in my back, but it's basically an Apollo capsule, which is a little larger. So the test that we were doing in there, that mock-up in the red, with the red thing is, if for any reason we had to do an AED, we had to use an AED on orbit because somebody's had a heart failure or got shocked and we need to restart their heart. How do you isolate that person from structure? Because structure has electronics. So if I send a volt through electronics, it's probably going to break. So we would need to isolate. So that's kind of what that's going on there. Just some tests that we do and try to figure out some designs or ideas how to do that. And I think that's my last slide. So if you want to jump into some questions.
All right, great. Thank you so much, Duane. That was really an awesome story. What I thought's really cool is that it's different. And it's different compared to what now has become kind of the traditional disciplines of biomedical engineering. So it's a really wonderful example of how BME fits into something else, or an industry that, as I mentioned in the beginning, that people don't really associate with biomedical engineering. So, okay, I want to remind everybody that you're welcome to ask any questions, and I think anything goes. Is that right, Duane?
Anything goes. If
Anything goes. The and you're welcome to chat. You can also unmute yourself. We don't have too many people. We can try it, see if it doesn't get chaotic. While we just to kick things off, let me just ask you, Duane, how did you actually? I'm always really interested in people's story and how they map their interest to their career. How'd you find the opportunity about NASA? You mentioned you moved after working on wheelchairs. How did it come about? How did you make the jump?
Yeah, so I mean, it was really more driven by location, right? So I was living in Baltimore. As I said before, my family lives in South Florida. I really wanted to get back to Florida. I really wanted, a lot of my friends that I graduated are still in Florida. We wanted to move. So it was just kind of looking. And like you said, there's so many things biomedical engineers can do. And around the time I started, it really wasn't, I don't have a graduate degree. I didn't have a PhD. So there's certain things I couldn't do. And it was trying to find something I could do. And I came across, search biomedical engineer, and that's in the title of the job that I got. So I came across that position at JSC, and I applied for it, and here I am.
So, all right, great. Duane, I don't know if you can see the chat list. There's a question from Cameron Celeste. Cameron, thank you very much for your question. The question is, I guess before the Dragon Falcon launch, NASA was sending up astronauts to the ISS via the Russian rocket. Did this influence your work in any way?
So from my standpoint, there are pieces yes, and there are some pieces no. So we flew the space shuttle up until the late, I think it was 2009 or 2013 was the last shuttle flight. I probably should know that, but I don't off the top of my head. But so we were flying shuttle, and there's, when we fly the shuttle, we launch from U.S. soil. We train astronauts here. We, everything we do is at KSC for the shuttle, and a lot of this training here. And when the space shuttle went away, the Soyuz was always flying, but now we'd have to fly to it more frequently because astronauts generally spend about 6 months on orbit. We've had a couple of missions that are year-long, and those are really research-based. But basically, we got to swap them out every 3 to 6 months in general. So if the only place you can do that is from Star City, Russia, in Moscow in Kazakhstan, then it poses challenges because there's training, it's a different vehicle, how you prepare for it, and also what you can carry. Because the shuttle was like a pickup truck, right? You toss a bunch of stuff back there. They had these things called MPLMs. They're basically containers, like pod containers that you pile stuff in and then you attach it to station, you can unpack it. When you go to Soyuz model, you don't really have that, right? Can't carry a lot of capability. It's called what we call upload capability. And honestly, that's one of the hardest things to do in spaceflight is getting stuff off the ground. The amount of propellant and propulsion it takes to get something off the ground is just not easy. That's why going to Mars and Moon is difficult, because just the amount of fuel it takes and all of the hardware you need to carry. So some of our hardware had to change, and yes, it affected us. We had to deal more with Russia. I currently have 2 docs that are permanently stationed in Russia for the capability to help take care of astronauts, NASA astronauts. But from our day-to-day in MCC, it probably didn't affect us, but the logistics of just getting crews ready and getting them in the vehicle and ready for the vehicle probably changed drastically after the shuttle. With the onset of SpaceX and Dragon, we hope that that capability comes back to US soil and we can fly more frequently. DM2, which is the SpaceX Dragon vehicle, that was actually a test flight. So it's not necessarily our normal flight. That was kind of a test flight. That's why we only put 2 astronauts on there. But once we're able to fly more frequently from US soil, I think we may go back to more how we did things in the shuttle days in terms of preparation, and definitely a higher need for people here in the US and NASA to prepare for those flights.
Okay, great. I'm going to jump back to your experience while we wait for more questions. Can you comment on what aspects of your undergraduate experience that you still use? You have actually a unique path in that you've been there for 18 years. So you've moved up and had multiple jobs, many different responsibilities at NASA. Can you comment on what you've learned there and what you've kind of built upon from your undergraduate career?
Yeah, so when I was at UF, again, it was an immersion program, and I feel like when I was there, we took a lot of the weed out courses for the other engineering programs. We took circuits, thermodynamics, dynamics. It was just a lot of weed out courses because they didn't have I wouldn't say they would have a full workload for the BME program. So what that taught me is the ability to work with others, right? And when I was there, our design project, we were able to define what our design project was. And then there was a Biomedical Engineering Society design competition. It was was my last year there, and we participated in that. So what I learned from a lot of that is being able to work with other disciplines. So specifically in the design competitions and the senior design projects, we reached out to other colleges. We reached out to the human health and performance colleges and work with occupational therapists, work with the athletic exercise folks to work on collaborations. And the reality is, regardless of where you end up, that's probably going to be the crux of your day. And BMEs more so than not, because what I feel like my role is as a BME here is to play that middle ground between design engineers or mechanical engineers or aerospace engineers that are hardcore design folks and the physicians, because I can somewhat talk both languages and link that bridge between them. So some of that experience of working in multidisciplinary teams was very key and very important. I still use it to this day, and I probably have for the entire 18 years that I've been here. And I feel like you have prepped me fairly well for that.
Okay, great. We have a question from Jean-Pierre. You can read along in the chat room, Duane. It's, when NASA reaches out to contractors to develop and design equipment, do you know what kind of specific quotas or requirements they look to highlight, such as weight limits, size limits, to fit in storage compartment? It sounds like our design requirements defined.
Yeah, so how these work is generally NASA has a procurement process, and and it's the government in general, how do they assign contractors, and they'll write very generic concept of operations of what they want to do, and then not really with a defined requirement set, maybe an overarching concept of operations type requirements. But once they get a contractor on board, they will develop a level, like what we call a level 1 requirements. It's really high level. There is no implementation for what kind of design it is. It's kind of like you were saying, you have to carry 50 pounds, or, it has to, it can be no bigger than this size because that's the size we have to deal with on the vehicle. And then the requirements are very high. So once they bring the contractor on board, that's when you get that's when the systems engineering magic happens, and you get the varying levels of requirements, which end up into really a design requirement on what to build.
Okay, great. Spencer asks, why in the world did you refer to astronauts as bags of water?
Yeah, so that's something we say with the doctors because, basically our human body is made up majority of liquids, right? So, it's a joke that we say that they're taking care of the bags of water, and we're taking care of the hardware to take care of the bags of water. So, I will say astronauts are extremely smart people, and by no means am I trying to say that they are bags of water, but the reality is, taking care of a human in space, in zero gravity, in a harsh environment is we tried to you tried to break it down, the level of care, to a really simple thing, because everybody thinks we can fly an MRI or we can fly a CAT scan, and the reality is we don't. So, and we just physically can't. So for one, we try to fly healthy people. They are extremely screened on the ground, that especially in this recent launch with the pandemic going on, they're heavily screened and protocols are put in place to keep them safe. And there's a lot of genetic testing looking at, whether they are able to fly or not able to fly. And then when we get on orbit, we prepare for some things. There's some things you just have to prepare for. Fire. One of the big risks is dental care, because, over time, we don't want to give them bland food or horrible food, but the reality is if somebody created an abscess on orbit and their tooth, and it causes them so much pain, that may be something we have to bring them home for. So we talk about, do we want to bring them home or do we want to treat it on orbit? The level of care that we have, I wouldn't say it's a hospital ER level, but the reality is we try to, since we have limited capability to carry hardware on orbit, we try to figure out what is the most likely. And we have tools, we have, statistical tools that help us determine what the highest likelihood injury could be. And that's what part of HRP does, is try to identify what the greatest risk is. And then we mitigate those risks with things we can control, like hardware or procedures or testing or education. So.
Right. Catherine, Noel, and Cindy ask somewhat related questions. They have to do with the hardest part of your experience at KBR NASA, the culture there, and what do you do on a daily basis? Can you comment on what your daily kind of work is like and what's tough?
So I'll say so I'm reading the question, what has been the hardest part of your experience at KBR NASA? So what I will say is people at NASA are really smart, right? And there's a lot of passionate people. So, and that passion comes out there, majority of so I will say this, a lot of the biomedical engineers that I work with didn't realize we could work at NASA. And a lot of us really, it wasn't on our radar at any time in our life. But a lot of these folks that work in other disciplines, they've known they wanted to work at NASA and be a flight controller since they were 5 years old. So they are entirely geared towards that. So that passion comes out. So when you're dealing with very passionate people and smart people, you almost have to step your game up and meet that, because as a team, we want to keep the astronauts safe. So it's definitely a high level of to bring your A game, to be able to support operations and keep crews safe. That's been challenging to keep up with that. And I will say it's somewhat competitive. It's not cutthroat competitive, but it is competitive in the sense of, hey, everybody else is here thinking outside the box to solve this solution. I got to come up with some solutions too, from my perspective, and what could affect me. Because if you just become a yes man, or you become somebody who just falls in the shadows, then what you're representing and what you're doing is going to lack. It's gonna show. If we get complacent, or if we get comfortable with a certain level of success, then that's when errors happen. So the hard part is just keeping up, being fully engaged all the time, being passionate, and keeping crew safe and speaking up when you need to say. So I'm reading through some of the other ones here. So what does a typical day in your job look like? Well, the day of my job now looks different than it did when I first started, but I would say that NASA has a lot of meetings in general. There's a lot of meetings, there's a lot of talking about requirements, and there's a lot of managing of risk. I will say for a new engineer that comes into my group, there's a lot of training because again, you don't come with a lot of history of NASA and you don't come with a lot of history of what we do. So we spend a good 2 to 3 years to train you, to get you, to sit in that room in MCC, you have to be certified. There's a certain certification that you have to pass. There's tests you have to pass. So we train you to be prepared, and we don't want you to fail. Our goal is to make you succeed, because any time we invested in you, if you can't get certified, is a loss for us. So we do what we can, and you spend a lot of time studying. You spend a lot of time working small projects. You can get assigned small projects. A lot of our guys now sit sims. There's simulations, which is basically just, fake missions with known scenarios that will happen, known malfunctions, and how you react to it. Do you use your procedures? Do you use your protocols to mitigate those issues? And then a lot of it is OJT. Working OJT real time is working side by side with a certified flight controller to see how it goes on a daily basis. But a lot of meetings, in general. There's a lot of meetings.
Just to follow up, your typical day when you started out 18 years ago, I imagine it was much more technical, and now it's more, I don't know, leadership. Can you comment on the difference?
Yeah, so definitely, and I think this is any career that starts off early and somebody finally progresses through the food chain, I guess. But yeah, initially it's very technical. It's looking at schematics, it's understanding drawings, it's seeing where preparing for failures that could happen and being prepared to answer those questions. Now my day-to-day is more resource management, making sure all the people are in the right place, making sure we have sufficient staffing levels, make sure we're interacting with NASA so that we're meeting their needs because we are a contractor. Yeah, so it has definitely changed over the years.
Okay, great. We're gonna try to catch up to some of these questions. Parker asks, what elements of healthcare, surgical procedures, emergency medicine have been explored in space, and what are the big challenges?
So surgery in space is a big topic because a lot of the outside world thinks it's easy, but ultimately it's not. And ultimately to keep a sterile field in space is pretty much impossible. So we don't do much surgery. There's a lot of wound closure. We prepare for wound closure. Could be, somebody's on an EVA and they get hit by something or they get injured. There's a lot of, we have a lot of hardware that can help with wound closure. And sorry, I paused because my computer said I had 10% battery, but I'm kind of flustered. I may have to run and go get a charger here in a second. But we do explore surgery because we know if we go to Mars, we'll probably have to do it. It takes about 6 months to go to Mars and 6 months to come back. So it would be naive for us to think about if something happens on there, we can't treat them. So it is a part of our research, but ultimately for ISS, a lot of our stuff is, very, if from a medical perspective, very rudimentary. We equate it to wilderness medicine. We do a lot of analogs and testing with wilderness medicine and remote medicine for simple things like, if somebody got a kidney stone, how would we deal with that on orbit? If you've ever had a kidney stone, it's extremely painful, and it could go south fast. So, so I wouldn't say we're high level for medical care. Our level of care is very low, but we understand that for future missions, we probably would need to increase the level of care.
Okay. Duane, are we going to lose you for a second?
Yeah, if you can give me 5 minutes, I'll go run and grab the charger.
Okay, go for it. We'll pause. Okay, everybody. I just wanted to thank everyone for participating in the questions. We'll try to get to all of them. we have about 15 more minutes. But I think these are great.
Okay, still there?
Still there. Duane, we have a handful more questions, but I want to jump in with one. You know, I noticed actually, I recognize some of the names of the participants, and there's a mix between graduate students and undergraduate students. So I have a couple questions. Can you comment on uh, your success in not going to graduate school? It seems like you've been very successful there and you moved up the ranks. You know, undergraduates, they, at least in biomedical engineering, about a third to half of them go to graduate school or feel like they have to go to graduate school in a couple years. That's not always the case. Can you share your perspective on the value of graduate school in a certain career?
Yeah, so it seems like recently a few of the hires, actually we just hired two people in that same job that I started with, and one of them has a graduate degree and one doesn't.
Okay.
So, you know, we are taking graduate students. It comes in, but it all also depends on what you want to do, because from my standpoint, when I first started, I always thought a graduate degree could exclude you from certain things because you're too experienced or they couldn't mold you or something. But I do interact with a lot of folks here. There are a lot of folks at NASA that have graduate biomedical engineering degrees, whether it's a master's or a PhD. We also have a handful of people that are PhD MDs. It's the full gambit. From my perspective, I felt like for me, coming in with a undergraduate engineering degree and building my career through what NASA wanted me to be was beneficial for me. But you know, I have a lot of colleagues that I work side by side with, and they came in with a graduate degree. So,
Now,
uh,
did you have the foresight, 20 years ago when you were starting out that you were going to actually have that growth opportunity within the company? Or, yeah, no, okay. I know a
now,
lot of students stress out about that, but the reality is big companies, you can move around and do a lot of stuff.
I will say that. So I will also say so. The company that I work for now has changed names 3 times because they were bought out 3 times, right? And each time we dramatically got larger. And ultimately, where we are now, they own pretty much all the operational contracts here at JSC. So there's multiple other contracts. You know, BME is just one discipline, but there's other disciplines like ISS systems, like the environmental system or the power system, or you know, I don't know, you can name it, the computer system, and their contracts for that also. And the company I work for has all of those contracts.
So, okay,
Yeah,
we'll get,
when I came out, I was almost, you can almost say naive. We really didn't have, you know, I think what you guys are doing are great. You're bringing people in industry to the folks, to the students, so they can see what it's like and understand it. You know, just because of the infancy of the BME program when I was there, I really never had this interaction. It was kind of a black box to me. I mean, half of my class went to medical school or dental school or law. Um, a couple went to graduate school, and there were very few of us that actually went out into world to work. Um,
I think that's a great comment because for a lot of faculty, it's a black box as well. The reality is we don't have much experience. So I find it always interesting. Students come to me and I actually don't have the experience to really, to guide them. But let's get back to the questions. There's your last comments are a good segue to Vanessa's question. She asks, and you touched on this earlier, but what courses would you recommend students to take to be helpful in the BME industry?
so for me, it was the design classes again. You know, I was in any obviously you have to take the minimal courses to graduate and the weed out courses and whatever. But you know, as you BME is so broad, you need to find what your interest is and then go from there. But I would always look for those opportunities to collaborate. You know, collaborate with other disciplines. Um, you know, we worked with the exercise lab, and we worked with, you know, at UF, we worked with one of the exercise professors to develop a piece of exercise equipment for our senior design. We worked with the OT and PT school when we were for that design competition to to develop a piece of hardware, which was an attachment to a wheelchair. So I cannot stress how important it is in the working world that you could be the smartest person there is. And, I've seen this, I've actually seen this where there's a lot of brilliant people. There's, a lot of people that have the highest degrees, get the best grades, and they get into the workforce and they're unable to interact with other people. So what does that do? They can't use their tools to be able to do their job because they have such trouble interacting with others. So the experience you get from working in collaborative teams and diversified teams pays off tenfold, because at any moment I could walk in a room and I'm talking to a doctor, or I'm talking to a PhD MD guy who is off the charts, or I'm talking to the CEO, or I'm talking to a finance guy. And something that I've learned in the past couple of years is really business, managing dollars, somewhat low level accounting of dollars. So it's getting that exposure, how to interact with other people and working in multidisciplinary teams, I think is key.
Yeah, that's a great comment. Okay, Jean-Pierre has another question. I don't know if you're following along, Duane, in the chat, but this has to do with astronauts. So many have military pilot experience, but are they actually medically trained, and how dependent are they on what you do?
So historically, yes, a lot of our astronauts are military pilots. I will say going forward, that is probably not the predominant background for astronauts. They like STEM. So probably one of the biggest increases in type of astronauts are medical doctors, because one requirement that we have for long duration spaceflight, if we go beyond low Earth orbit, go to the Mars or go to the moon, is there has to be one physician part of that team. There has to be a person who is a physician, an MD, a DO, to be part of that team just to handle any medical contingency. So teams are diverse. And ultimately, NASA's goal is not just to fly vehicles. Their goal is to do science. So we have veterinarians, we have geologists, we have microbiologists. It's a broad gambit of astronauts now. And I will say, from the medical training, each mission or each crew, which a crew could be 3 people for Soyuz, one person is designated what we call the CMO, which is a chief medical officer, and they get extra medical training. So they get the most in-depth medical training, and they are kind of responsible for the medical care for that group. They all get some level of care, because then we talk about, well, what if the CMO goes down? Who takes care of people? So, but for our purposes, there is a CMO identified. They get a lot more medical training than anyone else, and they get more familiar with the hardware.
Okay. Well, everybody, we have about 10 more minutes. And Duane, if you don't mind, we're going to try to get through 4 more questions that were asked. I think they're all great ones. Cameron asked another question. Hers is, can you just share what the most interesting problem you've worked on? Your favorite, maybe?
Hardest, most interesting. So, I don't know. I've done a lot of cool things. I think being part of a program that I was at the start to see requirements to see Dragon take off the ground is astonishing to me, because in the NASA world, programs take decades to develop, right? I mean, shuttle took decades. We have NASA's working on a vehicle now. It's Orion. It's going on 2 decades in development. The Dragon program was less than a decade. So it was very interesting. It was very encouraging, and I was in awe of how quickly it developed. And I was, just one more thing about hardest things, it's mishaps. So I've only been here for 1 mishap. NASA's really had 3 major mishaps where they've lost astronauts: Apollo, Columbia, and Challenger. But I was only here for the last one in the early 2000s. And I will say, we're a team. Astronauts are who we are responsible for. Ultimately, they are why we are here, to keep them safe. So when something happens or somebody dies for some reason, it's tough. It's challenging. How do you recover from that? I remember on the shuttle that broke up on re-entry, one of the flight surgeons that we work with, his wife was an astronaut on that flight. And, how do you deal with that? There's dynamics there. How do you work on that? So that's the challenging part, is keeping astronauts safe, and you always want to do your best. But it's definitely, I am very grateful for what I do. I get to walk into MCC and look at astronauts in space at any time I want. I can go and be part of training with crew members. So there's definitely great benefits.
So, Dwayne, you've already touched on the kind of spectrum of skills and talents that people have that you work with and the multidisciplinary teams. Uh, If you're hiring, what do you look for, kind of in a young engineer, whether it's an undergrad or graduate student?
Enthusiasm. So, you know, someone who knows what they want, you know, they say, you may have heard the things, resumes usually only get like less than a minute in a manager's hand. And that's the reality. For this last posting we had over 100 applicants, and I could only pick two. So, and I'm getting pressure to hire as quickly as possible. So we quickly scan resumes to pick out who we think are the best people. Did we miss some good candidates? Sure we did. But the reality is I have to find someone out of that list of that stack of 100 people. So we look for things that jump out: enthusiasm, experience, internships, co-ops. Those things show real world experience, as opposed to somebody who is just, been in school all the time and gets great grades. You need to really separate yourself. And those are just some of the qualities we look for. And of course, the interview process, it's enthusiasm. It's asking questions. Not everyone knows how to ask good questions. And it's pretty obvious when people ask questions. So if we're going to put you in a team of people where you're the sole representative of my group, I want to make sure that I'm confident that you can handle yourself and ask the right questions.
So this is a dangerous follow-up because I teach a kind of biofluids class. Do you ever hire someone because they can solve a fluid dynamics problem?
Not really.
Oh my gosh. Okay.
I'm sure there are people, but in the operations world, I'd say no. We do develop some hardware that'll look at that with fluid dynamics and zero gravity, but that's just not in my area.
Yeah. Well, that's okay. That's good news because that's what I tell the students who don't like the class too much. I say, oh, don't worry. You won't get hired for it. Okay. Winston, who's a graduate student in our department, has a question. And I don't know if you can see it, Duane. What went into your decision to work on operations, research, and planning as opposed to sticking in that first initial department that you had?
So when I first got, and this is something that I came to conclusion on. I'm not sure everybody has the same conclusion because there's definitely people who climb the ladder, right? So when I got there, I was a flight controller for about 5 years, and there's very little opportunities for advancement. I will say that in any organization, it's a pyramid. So as you get higher, the opportunities become less. So again, I'm going against very smart people. I'm going against people who are very motivated. We're all doing great jobs. How do you distinguish yourself from someone else? So what I felt like I needed to do is I needed to take every opportunity I can, regardless whether it was in my wheelhouse or not, and challenge myself. So when I went from operations to research, that's completely like the opposite end of the spectrum in my world. So I went to research, learned how to do that, seized opportunities, and then moved on to the next thing, to develop requirements, work in systems engineering. And then what I bring back to where I'm back at to now is things that people who decided to stay in the group don't have. So I've tried to more diversify myself because I have a background in research. I have a background in development. I have a background in operations. So I try to make myself look, different, make myself have qualities or experience that other candidates didn't. And luckily it worked out. I mean, the guy that I replaced in my current job, he did it for over 25 years. So, he wasn't going anywhere for 25 years. So it's not, if I couldn't wait him out. I mean, he's my boss now because he moved up one and I took his role. But the reality is sometimes you got to go challenge yourself. You got to be uncomfortable. You got to grow. And the only way to grow is to challenge yourself, to do stuff that is hard and learn how to overcome it.
So I think those are another great message. Okay, our final question maybe is one from Rohan. This has to do with surgeons, but what do doctor surgeons play in improving, or what role do they play in improving medicine in space? Do they have input into what you do?
Oh yeah. So the doctors and their flight surgeons, they're key players in it all, right? Because they have a relationship with the crew members, and sometimes things come across they have a different perspective than most. They're with crew members all the time. They go hand in hand. So the doctors are definitely key in defining a lot of what we do. I mean, in anything, in vehicles, how many G's a vehicle pulls in what axis it'll come in at could kill somebody. So, they are definitely a key part of it. I will say, to be a flight surgeon, to come work at NASA, you have to be a aerospace medicine residency. And currently, I think there's only one civilian aerospace residency program now. There used to be two, but one folded. The only one's at UTMB, which is University of Texas Medical Branch, and that's in Galveston. We have a few flight surgeons that come through the military. That's a little longer, harder route. But if your aspiration is to be a flight surgeon, and I would get involved in the aerospace residency program at UTMB. There's a lot of summer programs that they bring students in for, and to gain that experience, because again, they also look for enthusiasm. They have a broad pool of people to pull from, so they're looking for the ones that stand out.
Duane, is there much turnover at KBR NASA, job-wise?
Not really. In my area, we're kind of secure. We do get those folks, like I said, the opportunities as you go higher are limited. Some people are impatient, and in the normal world, it could be easier to move up the ladder. It's a little bit difficult in the NASA environment, so some people do want to move on and do other things. But with my company having a lot of the operations contracts now, it's becoming easier to go do things in another group. So I could go work another system. It's easier to do that for me now. I have no plans to, because I love my system. But the reality is, if you're a younger engineer, because we don't just hire biomedical engineers, we hire mechanical engineers, aerospace engineers. I think we even have a chemical engineer. So, you could go do other systems also. So, I would say attrition's about similar to other companies, but the reality is, a lot of people here are here because they're passionate about the space program.
So, okay, well, Duane, somehow we're out of time. So I just wanted to make sure that we thanked you for spending the hour with us. You mentioned enthusiasm multiple times, and definitely what came across, to me, and I'm sure all the students, is your enthusiasm for your job. And that's actually exactly what the vision for this kind of BME industry insider series is all about. So we're really lucky that you kicked us off today. So
yeah, thank you for inviting me, and thank you for Ryan for reaching out. I think Ryan initially reached out, and we were able to get on the chat and talk a little. Again, what I told him is my goal is to get more Florida grads here. Florida produces great engineers, and we have a need for great engineers. So, I'll do what I can to help do that. Whether it's notifying Ryan of things that come open, or opportunities that come open, or where we can collaborate. We have internship programs, we have co-op programs, so definitely open to all that.
All right, wonderful. Well, everybody, that officially ends kind of our hour and Duane's visit with us. So thank you very much for everyone for showing up, and we'll just thank Duane again.
Thank you. And go Gators.
Duane, really appreciate you taking the time. This was awesome. I'm glad that you were able to join us and share some of your experiences, because it's pretty fascinating. And I think we've mentioned it a little bit. We just haven't had a lot of this kind of stuff with BME here. So awesome way to kick off this little series that we're working on putting together.
Awesome.
All right, Ryan, anything else?
I don't think so. I think that's it. Yeah, that was great. I recorded it, and Duane, if it's okay with you, I think we'd like to be able to upload it to our YouTube channel and at least have some shared access to it. There's somebody else that might want to check it out that maybe couldn't join us today.
Yeah, I mean, I'm fine with that. So, and if anybody has any questions, you have my email. I'm open to taking questions. So.
Very cool.
Yeah, great. And Duane, thanks for making it easy. It was like perfect logistics. I don't know, timing of everything. So, and it definitely was cool. It's something that stimulated tons of questions. So
cool.
Thank you.
And Ryan and I didn't mess it up too much, did we? At least I don't think so.
No, Lee, thanks. That was great. Candy, appreciate your help. Yeah, Lee, really thank you for helping us out with this.
Well, Duane made it easy.
Yeah, it was easy.
It's fun stuff. So space is fun.
Thanks, Candy.
You're welcome. Thank you, everyone.
All right.
Okay. All right. Nice seeing you, Duane.
Bye.
All right. Good luck with everything.
Thank you.
All right. And look forward to seeing you soon, hopefully.
Yeah.